Thank you very much, Arnold. So for those of you who don't know me, my name is James McGrath. I'm an assistant professor at Maynooth University. I suppose I've recently moved here just over 2 years ago, where I was based previously in the University of Galway, where I was actually involved in this project, I suppose, from the start. So I suppose just to give some initial context to where we're thinking of this project, in particular the schools project in the Irish context, the Irish government set out a target to try achieve a 50% improvement in the energy efficiency of the public sector buildings. So in Ireland, most of our schools fall under this public sector remit. And the idea was that the public sector would serve as an exemplar case to incentivize the private sector. And where these retrofits, I suppose, were falling under was SEI, which is our Sustainable Energy Authority of Ireland. So they were very keen to gather evidence on how essentially energy efficient buildings and particularly how the retrofit scenarios were playing out in the Irish context. And that's kind of where the concept of this project, I suppose, has initially come from, I would say from a funding perspective. But just, I suppose, some context in the Irish context, we say Irish classrooms and I should say the traditional Irish classrooms have had a typically higher occupancies compared to the European average. So older classrooms could have had anywhere between 25 to 30 students in a different classroom. And particularly some of the classroom environments that we look at have actually served as multifunction environments. So if we look at the older classrooms or the traditional buildings that we've investigated here, that they could, for example, be obviously the teaching environment, but they could also be where arts and crafts take place. On rainy days, there mightn't necessarily be a custom cafeteria, for example. So lunch and everything else could be ate in the classroom. So obviously that impacts the occupancy profiles, but it also, I suppose, just highlights that ventilation isn't just required now from a teaching perspective. It has to adapt to a range of different kind of activities that are happening in the classroom. So what was proposed is we proposed on what we've nicknamed the Benefit Project, and it was really trying to look at the consequences of indoor air quality and occupant comfort in energy efficient retrofits, explicitly targeted at the non-domestic sector, so offices and schools. But I suppose as a part of that, we had a separate cohort that were trying to look at the indoor air quality in newly constructed buildings. So we were trying to see was the consequences of retrofit just due to air tightness and in line with newly constructed buildings, or was there actually a distinction between the two of them? And I suppose just to acknowledge everyone else involved in the project, I said I'm not the day-to-day researchers in this project anymore. So all the work goes to, I suppose, different people. I'm kind of here taking some of the credit. But on the left-hand side is Dr. Miriam Byrne, who's in the University of Galway, is the PI in leading this project. Dr. George Fernandez, he's the postdoctoral researcher who's looking at the newly constructed buildings, and Adam Collison, who's a PhD student who's looking at the pre and post analysis of the project. So I have to say, I'm very much presenting Adam's work as part of this project, just the element that we're zoning in on. So all the credit, I suppose, of the hard work goes to Adam. So these are, I suppose, the three different cohorts that we've kind of broken down into the essentially older buildings that are being retrofitted, and they're what I'm going to focus in on. Again, very much Adam's work, but there's two other cohorts to this broader project that are still ongoing at the minute. So the broad scope of this project is we've kind of had, I suppose, the recruitment. We facilitated a pre-monitoring stage followed up by a post-monitoring stage. But within each stage, what we've done is we've a short-term precision grade equipment to try gather data on the key pollutants. But this is mapped then again trying to capture longer-term trends as well. So we can see the fluctuations from week to week and across the different seasons. So this is a combination of, I suppose, more research grade equipment and then the adaptation of low cost or consumer grade sensors as well. But this is very much complemented then by, I suppose, the survey design, which has been facilitated through walkthroughs in the classroom and capturing building characteristics, the retrofit characteristics, but also then the occupant satisfaction and the perceptions of the different participants in these environments. And then, so we've completed, and I should say Adam has completed all the pre-sampling that as of, I think it was June 2024, but actually I think of just as of last week, we've actually completed the post work as well. But just for the sake of this webinar, what I've done is we've just focused in on the pre-data that we've collected, which kind of represents, I suppose, the more traditional, conventional classrooms in Ireland. So when we look at the short-term data, and again, I'm just going to focus in on this for now, just for the sake of, I suppose, time constraints, but happy to discuss it with anyone else afterwards. So the key pollutants that we looked at, and particularly in real time, were PM 2.5, and what you won't actually see is, but I don't know if you can actually see my cursor, but inside in this wooden box is actually where the PM sensor was located. And there's actually a specific little inlet that we designed here. So we had to develop a customized box, essentially, that had a sound suppression system to reduce the noise, because essentially the optical measurement had an active pump. It was actually quite disrupting. So we had to develop this custom box actually to reduce the noises of influence in the classroom environments and the office environments that we were looking at. The grave was then measured to look at carbon monoxide, carbon dioxide, TVOCs, temperature, and relative humidity. And I don't know if you can see, is the white circular was the AirThings device that was actually used to capture the longer term data. So similarly, that had temperature, relative humidity, CO2, VOCs, and the radon was captured through this. Some of the other pollutants that were captured, and these were captured through very much passive monitoring, so either diffusive badges, was formaldehyde, NO2, limonene, pinene, and then BTEX. So all of these were measured for 7 days, I think, with the exception of nitrogen dioxide, which was over a 3 to 4 week period. So just to give, I suppose, a broad overview. So again, the study has looked at non-domestic, so it does encompass offices and schools. I suppose just for the sake of this presentation, we focus in explicitly on the school data we've collected. There is some office data in just to allow comparisons between it, but we're primarily focusing on the schools. So what you can see on the map, hopefully on the right-hand side, is just the spread of the classroom environments and the office environments throughout Ireland. Just for those who don't know, this Maynooth University is just outside of Dublin. We're about 25 kilometres outside of Dublin city centre. And then on the west coast of Ireland is University of Galway. So the schools in Ireland that we classify them as are broken down into two main I suppose, age profiles. And I know these varies differently in some different countries. In Ireland, what we do is we classify them typically as primary school and post-primary. So post-primary is typically probably the equivalent of high school, which in the United States. So all of these environments were naturally ventilated. Typically, most of them are more than 50 years old, and I suppose in line with those that were identified to be retrofitted. The median volume and floor areas of these environments was 180 meters cubed and about 63 meters squared. But what we can actually see then was the median class density was typically about 2.1 meters squared per person, with a standard deviation of about 0.5. That includes obviously the teacher and the students in these environments. And just, I suppose, for context, so everyone's clear what we mean when we say naturally ventilated, because I know sometimes that can be considered just, I suppose, infiltration. But in Ireland, natural ventilation, I suppose, is purpose-provided ventilation, we should say. So it's a passive wall vent, and hopefully you can see the arrow up on the top, the blue arrow pointing into it on the wall. There's a second one, I suppose, between the other two windows. So the idea is this essentially is naturally driven. So it's a pressure differential between inside and outside to supply the air in these environments. So when we start to look at some of the data associated with this, particularly what we can see is the PM 2.5. The first big, I suppose, conclusion was we typically exceeded the WHO guideline limit, the 24-hour limit of 15 micrograms per meter cubed, about half of the time. 48% of our days exceeded this value. But when we look particularly at the school values, what we can see is on the top graph initially, we can see is there's a strong correlation with the outdoor PM 2.5 influencing the indoor environment. And that's, I suppose, typical of what we probably would expect. But then if we look at just the bottom graph for a second, which is the normalized data across all of the data set, similar we see the strong correlation between indoor and outdoor. But I think what was a particularly interesting aspect, and it's probably slightly more unique in the Irish context, that if we look in at the occupied hours, so if we examine when we examine the occupied hours versus the total hours, we actually seen that the occupied hours had a lower average than the 24-hour average, because what we're seeing actually is peak concentrations occurring after hours, particularly after 6 and 7 o'clock in the evening, which is largely due to residential solid fuel burning in Ireland. and we were able to map this up against the outdoor concentrations in certain regions. So actually, I suppose it just highlights an opportunity, I suppose, I won't say opportunity, but a knowledge that we can't just simply look at 24-hour data, average data for schools or gravimetric data, because I suppose we can actually be capturing events that aren't always representative of in classrooms. Typically, sometimes we see the opposite in other schools where it's more associated with traffic. But the big thing is we do see these significant temporal fluctuations occurring. If we continue, what we see now here is all of the PM data on the left-hand side, which is the PM data across each of the individual schools averaged at a building level. So the S01, C1 stands for School 1, Classroom 1, S1, C2 represents School 1, Classroom 2, and across the data set. So if we typically examine this, what we do see, and it is kind of what to a degree of what we would have anticipated, is that the classrooms are largely representative of the school as a whole. So for example, if we look at just the first two box plots, we can see that the median values are comparable, which would reflect, I suppose, the broader influences of outdoor air. If we look at, for example, we'll say look at school 4, classrooms 1, 2, and 3, again, have this similar trend. Okay, there's a spread of the data in certain environments, but largely the median values are comparable. And particularly if we see the distinction between classrooms 8 and 9, that becomes evident as well. But when we map some of this against the CO2 concentrations on the right-hand side, we can actually see, I suppose, it's some of this trade-off, the consequences of natural ventilation, that where we've actually lower CO2, we are actually seeing evidence in certain cases of higher PM concentrations due, I suppose, to better airflow, allowing more infiltration of outdoor air. When we looked at this then in terms of some of the PM data, looked in terms of the NO2 data, I should say, largely it was typically quite low, with the exception of one of the office environments. But when we looked at that, it was quite near, I think it was near a railway station that was actually facing into the environments that we were looking at. But apart from that, again, the same idea is we can quite see for the majority of them that the differences between the classroom environments that we were looking at was quite negligible. When we continue on then the analysis, I suppose, to the influences of CO2 indoors, what we do see is essentially the vast majority of the classroom environments that we were looking at, about 50% of them, of the environments, had 50% of the time exceeded 1,000 parts per million. And we can obviously see that by the cumulative kind of distribution building up in the data. But what was actually an interesting finding, I think, when we mapped this indoor CO2 concentrations against the outdoor concentrations, we, I suppose, essentially seen an inverse correlation. I suppose what we mean by that is the lower the indoor temperature, the higher the CO2 concentrations. So, sorry, I'm not sure if I said that right. I'll say that again. Sorry, the lower the outdoor temperature, the higher the indoor CO2 concentrations. And we were particularly in the classroom environments, and we were putting this down to the influence of the occupants and the teachers themselves opening windows. So the higher the outdoor temperature, more likely that they were increasing the ventilation, which was lowering the CO2 concentrations. But it was interesting that the correlation was more linked with the outdoor temperature rather than the indoor temperature itself. Similarly, and I won't kind of dwell on all of this, but I suppose when we looked at across the office and school cohort in terms of the EN standards, we were kind of seeing large periods of exceedances, particularly with, say, just if we look at category 4. So for those of people aren't familiar, typically category 1 is less than 970 parts per million. Category 4 is above 1,700 parts per million. So what we could see is, particularly in the school environments as a whole, okay, and there are some exceptions, but for the majority of the schools, we're actually exceeding 25% of their time was exceeding 1,700 parts per million of CO2. Just briefly, I suppose, conscious of time, is when we looked at some of our broader pollutants, the averages of our NO2, we typically actually found it was significantly lower than the global average. We only found 2.57 micrograms per meter cubed. But I suppose by contrast, which was interesting, our formaldehyde concentrations were actually kind of considerable, I should say, well, I suppose were considerably higher than the European median. So we observed an average of 20 micrograms per meter cubed, and we can see this data on the right-hand side. And we do see it was considerable variability across the schools and the office cohorts. And even in certain cases, there was more variability with the formaldehydes within some of the environments, particularly compared to some of the other pollutants. But actually, some of the other things we noticed actually was limonene. We actually detected a much higher rate of detection in the classrooms versus the offices. So we detected it in 16 cases in the classrooms, but only observed it for two cases in the offices. Now, that's not to say it wasn't present, but I suppose what I mean by that was above our limits of detection that we were able to quantify. Just very briefly, I suppose when we mapped some of these against our TVOC concentrations, we're actually able then to see the influence of certain activities. So I suppose not saying TVOCs has a health risk or anything associated with it, but it did allow us to look at the influences of occupant behavior or student activities, and we can associate some of these peaks, particularly with cleaning and disinfectant. These are some of the broad results, but again, I think I've talked on these in detail, so I'm not going to kind of elaborate on them. Just broadly to finish up, we have done the pre-elements. What we can see here is the pre and post analysis have occurred. And just very briefly, if we look at some of the survey results, and again, this is very preliminary, it doesn't include everything, but generally people are happier, more increased satisfaction. But as these situations have gone from natural to more mechanical ventilation, the familiarity with the ventilation perception has decreased, as well as the perception of its effectiveness. So all I'd say there is stay tuned. We're in the middle of writing up a paper, so hopefully this will be out in the next couple of months if anyone is interested. And then just to kind of, I suppose, sum up our broad conclusions, basically PM 2.5 exceeded the data over half the time. We did observe kind of influences of occupant behavior and ventilation patterns, prioritizing thermal comfort over CO2. There was a significant temporal variability in the PM, CO2 and TVOCs, which does highlight this need for longer term monitoring. And then I suppose we did observe the differences between intra-building variations and inter-building variations. And then actually formaldehyde was higher in our cohort, but NO2 was lower compared to previous studies, which was an interesting comparison. And essentially our post-analysis essentially is nearly complete. So stay tuned on that regards. And thank you very much for your attention.